So today I'm going to run you through what we determine as a mixed annual fodder crop and why you might be interested in using it, what's the benefits of it, a bit of a snapshot of some of the results that are coming out of the project, and then some of the early learnings to date that we're finding from that project as well. So what we mean by a mixed annual fodder crop is it's a combination of different functional plant types, winter annuals, and they predominantly come from cereals, the brassica canola family, legumes, and then also in some areas annual grasses such as annual ryegrass. So a typical mix might be something like oats, annual ryegrass, and a brassica, or oats, annual ryegrass, and a clover. And the idea is to match these different species types to coordinate a mix that's going to give you some resilience over some of that variable seasonal conditions that Sean referred to, provide you with a nice, even and diverse range of nutritional profile for your animals for grazing, but also potentially have some other benefits in terms of soil health, weed suppression, and a few other sort of environmental indicators. So typically if you had a mix of cereals, so say something like oats, that gives you a lot of, the oats is there to give you sort of the backbone of the mix. It provides a lot of the biomass volume and has quick growing features over that sort of autumn-winter period and gives you a kind of high biomass, high quality early in the season. Then something like an annual ryegrass fills in some of the gaps of that backbone by providing high quality feed with quick regrowth value. So it's consistently going to regrow over the grazing period. And then the brassicas and the legumes are there to provide some high quality at different points in that grazing season. So there's a mix to try and even out that feed base over that autumn, winter and into spring period. So why are we interested? Anyone on the Northern Tablelands, which is the curves at the bottom and the northwest slopes at the top, knows that in this environment, typically, we have that autumn, winter and into early spring feed gap because we are in a summer rainfall environment, so our rainfall in winter is less, but also because of the cold, sometimes that limits some of our pasture species and their availability and their quality. So we're looking for something to fill that feed gap. Typically, we've used a straight cereal crop. That can be, like as we said before, a straight oat or a triticale or a barley. And they're fine and they do a good job, but potentially they have some metabolic issues. So there might be a lower mineral concentration in some of that fodder that may limit some of your animal production, or they just don't actually deliver everything that you can have, and they sort of don't have a lot of risk buffered in there to try and make sure you've got something growing over that grazing period. So for some reason, if your oats fail, then you don't have anything else in that fodder crop to try and even out that food supply. So basically, we're looking to improve how we address that feed gap by looking at providing something that gives you a more diverse and balanced feed base for that livestock over that grazing period. Complement the other forages on your property, so you may be able to help use these fodder crops to help utilise dry fostered tropical grasses, for example. If you run tropical grasses on your property, you can sort of mix and match the grazing using these mixes to try and utilise those other sources. And then obviously that resilience to climate variability that Sean was sort of alluding us to, by having more species and a more diverse mix, you're going to have better chance of something being able to grow during that grazing season, depending on what sort of climate conditions you have. So there's a lot of reported benefits of these mixes, and I should point out they're not new. I mean, a lot of people have been doing them for a long time, but there's a lot of benefits, reported benefits, and then there's a lot of challenges that we've got to weigh up when we sort of think about how feasible using these mixes are in our grazing systems. So some of the reported benefits are, and we've sort of covered the first two, is that extended grazing period, increased biomass, higher quality feed across a longer grazing period, having a more balanced nutritional profile. So some of the things like brassicas and the clovers will provide more minerals. So potentially reducing those metabolic issues, and reducing the need for supplementary feeding, and that leads to the enhanced livestock production. And then there's reported benefits around soil health. So obviously if you've got a legume in the system, you're putting nitrogen back in. But if you're using some of these brassicas like turnips or tillage radish that also have, the ability to aerate the soil or break up some of the soil compaction, there's benefits there as well. And then there's obviously the suppression of weeds, and then the ability to help try and clean up weeds before you go back into a more perennial pasture-based system. Some of the negatives though, or less known challenges or less known data, is that there's limited local data. So most of the information we have comes from overseas or from farmer experiences. So not to dismiss those, they're very valuable, but we haven't really explored them in a controlled situation under Australian conditions, under our environmental conditions. And we also, there's not a lot of economic validation. So are they worth it in terms of increased livestock production or increased benefits to whatever your cropping rotation is if you're using them in a crop situation? Once you add more species to a mix, obviously you're going to increase the complexity of management. So you have to have a good understanding of how those mixes or those individual species in the mix will work, and what are the trade-offs in terms of management that we have to look at to make sure we get the best of those mixes. So there's things around sowing complexity, so you're sowing things of different seed sizes. There's management, how do you manage that mix to make sure you optimise all the species in that mix at their given growth period. So it just becomes a little bit more complex. Animal health risks, although we're potentially reducing some of those metabolic issues, there are other management requirements to make sure that you maintain animal health on some of those different species. And is it higher costs, less chance to do in-crop weed management if you're trying to control broadleaf weeds in a mixed species? So there's some of those challenges that we need to understand as well. So addressing that there's positives that have not been really proven in Australia, and then some of those challenges, the project was developed to try and evaluate those mixes and understand how they work in our conditions and how they might lead to increased livestock production being the ultimate aim. So to do that, we had three components. We had agronomy experiments, which were more small plot, looking at mixes in different environments, looking at different combinations of mixes. And that happened for 3 years at Wagga, Tamworth. Sue's ran the experiments here in Tamworth and Glen Innes. And that was looking at evaluating fodder production, quality benefits for a range of mixes. The ultimate aim wasn't to come up and say, this is the best mixture for you. It was just to evaluate what these different mixes are and understand how they might work in different environments. Then that led into 2 years of grazing experiments, one at Wagga and one at Glen Innes, where we were actually looking to quantify the animal benefits of mixed annual fodder crops, using animals in a controlled situation, which I'll explain a little bit more later. And then we also had 10 locations across the state over 2 years where we were actually taking some of these mixes out and looking at what was happening on farm in a large-scale situation and in a diverse range of environments and farming systems. So they were across the state. Just for your information, there was one at Glen Innes, one at Manila, one at Boggabri, Kidal in the central part of the state, one at Quandiella, which is near Wagga, and one at Pleasant Hills, which is on the other side of Wagga. So a good scattering across the state. Today, I'm just going to talk to you about the Northern New South Wales sites or data from the Northern New South Wales sites. We don't have time to go into the whole project, but if anyone has any questions about down south, then please feel free. So this is just a snapshot of some of the agronomy work from Glen Innes. And so you can see this graph at the top is rainfall. So the solid grey bars are the actual rainfall and the red line is the average. And then underneath that we have 4 herbage mass graphs showing 4 treatments that were sown in each year of the experiments we ran. 3 of them are mixes and 1 is oats. So the oats is the blue colour, the ryegrass is the orange colour. You can just see some grey colour there, that is the brassica. And if you've got very good eyes, you can see that there's a very thin line at the top of some of those end mix, which is a yellow line, and that is vetch. So the reason I put this graph up is to show that we did these experiments over 3 years. We had 3 very different seasons. As Sean has just pointed out, we had in 21, it was very wet, a very wet winter. I think it was the 2nd wettest winter in Glen Innes on record. The next year it was wetter than average, but not as wet as the previous year. And then in 2023, it was quite dry. It was a below average rainfall year, particularly over that autumn-winter period. 3 different seasons, 3 different graphs of herbage mass. So you can see in 21, we had quite a lot of biomass. I think we got over 30 tonnes in some of those treatments. So over the 8-month growing period. 22, once again, lower biomass, but still quite reasonable. And in 2023, they're very similar, but there's still slight differences between them. So the most sort of interesting feature is that in all of those years, the mixes did produce more biomass than the single species oats. And the composition within those mixes changed, varying depending on the seasonal conditions of the year. So 21, annual ryegrass dominated. It was able to respond to the rainfall much more reliably, and it dominated the mixes. There was a bit of brassica there, but it didn't really like getting terribly wet, so it wasn't there for the whole period of the time. And the vetch was there, but not really contributing much to the thing. 2nd year, once again, the mixes were quite dominant, and you can see that brassica was actually making more of a contribution to the mix that it was in. And then in the last year, although it's hard to see on this graph, the 2 mixes at the end actually were significantly higher than the oats only. So even though we had these variable years, the mixes were showing benefits in each of those years. So showing their ability to buffer that climate variability in both really wet years, but also dry years. So showing that resilience across different seasonal conditions. So you might say, well, what's the use of biomass and composition without some quality? So we've moved to Tamworth. This is some data from Sue's, where we've got oats at the top and then an oat, ryegrass, turnip and shardful clover mix. And you can see the different compositions within the mix compared to the oats. The oats has got 2 little red stars up there. That's where nitrogen was applied, whereas the treatment below that had a significant clover component didn't have nitrogen supplied. So if we look at sort of the main sort of nutritive value components that we look at, so particularly the crude protein and the digestible matter, you can see that there's not a huge difference between the treatments in terms of digestibility. The interesting component is the crude protein. So where the oats is the solid blue, like the solid dark blue line, and you can see even when we put nitrogen out, we've still got that decline in crude protein of the oats over time. There was a slight little bump in crude protein after the 2nd nitrogen application, but basically it plateaus out. And the crude protein of the mix is much higher. So we're sort of maintaining that nutritional profile over the grazing season compared to a single species. And Sue's used that data in a model to try and work out what the predicted intake would be. And you can see there with the mixture, which is that lighter blue line, that it kind of was quite even over the grazing period, whereas the oats was a bit more variable and ultimately kind of was declining. And the same with live weight gain. So this is just predicted live weight gain. We actually saw an increase in live weight gain with our mixes, but the oats, the general trend was downwards. So this leads in nicely to the grazing experiments. And as I said before, we've had 2 years of grazing experiments at Glen Innes, 1 in 2023 and 1 in 2024, which is this year. I'm just going to talk about the 24 one today. We had 3 treatments, oats, ryegrass and brassica, and then oats, ryegrass and clover, and the clover was arrowleaf clover. And those treatments were replicated 4 times. It's large plots, so each plot was a hectare, and so the total grazing experiment was 12 hectares, with 20 merino lambs grazing the plot, each plot, so 80 lambs per treatment. And we had a range of fodder measurements that we did, but they were done at day 0, so just before the animals went onto the plots, and then roughly every 30 days thereafter. So looking at that biomass composition, growth rate of the pasture and the quality. And then we had a series of animal measurements that we did around the same time, and that included animal weight, but also a select number of animals from each plot where we took blood samples to check out the mineral composition of their blood plasma. So quite a few measurements. Just quickly, I don't want to dwell on this, but just that shows you the variation in the treatments in terms of their fodder biomass and composition. The main differences are obviously that the oats is oats and there's very little weed in there, but the other treatments had a consistent, small but consistent level of annual ryegrass in the mix, and the brassica treatment had a significant component of brassica across the whole growing season. And if you can see in the clover graph at the end, there is a thin red line. So the clover was quite small component, but it was also consistent and there all the time, adding to the quality of the pasture. Now, we unfortunately don't have the quality samples back yet, and they're going to be a crucial piece of the whole picture to show us how that fodder quality declined or stayed even over time. If we move to the live weight and the average daily gain, you can see there that the oats only is the solid red line at the bottom, and that is significantly lower, particularly at the end of the experiment, which is day 91, than the other 2 treatments, which were the mixers. So, and if you look at the average daily gain, I'm not sure the pointer works. Average daily gain, little graph at this end there, you can see that there was a significant difference over time. So the oats was 178, the oats ryegrass clover was 195, and the oats ryegrass brassica was 213 grams per head per day over that whole 91-day period. And the little, the ABC at the end means whether that's significantly different. So because they're different letters after it, that indicates that that was a significant and real difference. So that was quite interesting. And then how does that actually compare to something like the carcass quality? So we were lucky enough to be able to trace these animals all the way through the abattoir and understand what was happening in terms of carcass quality data as well. So this graph this table is hot off the press. You are the first people to see it. It only occurred last week. So whatever trait you look at in terms of carcass weight, carcass fat score, the GR fat, so that's the fat on a certain rib, the dressing percentage, and then ultimately the value in terms of dollars, you can see for most of those traits, there's a significant difference between all treatments. But particularly the one of interest is the brassica, where we're looking at an end value. So these values here, these dollars per carcass here, are not taking out the input cost yet. So, but really the only difference in those input costs from this experiment will be the different seed costs. So we still need to do that economic analysis. But it's quite interesting to see that you can get potentially a huge difference or a significant difference in the dollar value per carcass from the different treatments. So this kind of indicates that not only is the mixes providing more pasture biomass, it's resulting in higher quality material, which is actually laying down more carcass weight and more carcass fat onto the animal at the end point. So there's potential there for you to not only increase your animal production in terms of the dollars received, but also maybe potentially use these mixes to turn off your stock quicker. And we all know turning off stock quicker is important to try and reduce our methane inputs on farm as well. So there's a whole range of benefits that we've got to tease out. This is really just preliminary data, but I'm really quite excited about the differences that we received. Another thing that we did on this grazing experiment is we've been collaborating with the Precision Ag team at UNE, and we've had collars on a certain number of animals per plot. If you look up there, you can just see the orange collar and the yellow tag on it. A number of these animals per plot were tagged, and then we were able to monitor their grazing behaviour and their movement around the plots. And then we're also, this year we had a whole set of cameras. It was like a Hollywood production out there. And so we now are able to look at what the data from the accelerometer was telling us, visually match that to what the animal was doing on the cameras, and then we can sort of come up with some understanding of how that affected grazing, like how these treatments may have affected grazing behaviour, which ultimately we use to understand animal welfare. So have we got happy, healthy animals grazing in our paddocks, and then also what those behaviours mean, and if there was any real differences that we can utilise for fine-tuning some grazing management strategies. Basically, the ewes were more active than the wethers, so it probably won't surprise the ladies in the audience that we're more active and we get out there and get jobs done. But overall, the activity differed. There was some differences in activity over treatments, and it was usually during those key grazing periods, not during the rest periods. So when everybody was resting, there was not really any differences. But when they were actively seeking out forage, there were some differences. Mainly at this stage, we can only really say that the ewes were more active than the wethers. So it's another great data set that's going to tell us a lot of useful information. As I said before, one of the key things about this project has been really having a look at what's happening on farm, so the on-farm validation sites, so trying to understand how it actually can fit into a real-world situation, not my nice little 12-hectare plot on the research station. So in the north, as I said before, we had sites at Glen Innes, Manila and Boggabri, and this is just a summary of the table from last year's sites. So we also had a site at Glen Innes and Boggabri again this year. It's not to kind of draw out any firm conclusions, it's just to show you the variability in the way that people are using these mixed annual fodder crops. So in Glen Innes, we had an oats versus an oats, ryegrass, tillage radish, brassica and woolly pod vetch mix. In Manila, that was an oats versus an oats, ryegrass, brassica. And then at Boggabri, it was an oats, and then the mix was oats, canola and vetch. Different classes of animals, from lambs to cattle weaners, different ways that we managed it. So in Glen Innes, it was just a straight paired paddock where we had similar numbers on each side, and we could monitor it similar to the grazing experiment at Glen Innes. But at Boggabri and Manila, they used multiple paddocks and they were rotationally grazing and they were tracking that performance around the paddocks. And I'm not an expert on either of those sites. If you want to know more details, Mark Brennan and Pete Perferman are sitting up the back and they can help you out during morning tea. But basically, the strong messages coming through was we were getting strong benefits from the mixes at each of these sites, but it wasn't, those benefits weren't consistent across sites. So sometimes it was an increase in biomass, or sometimes it was a very significant different nutritional profile. And other times it was an actual average daily gain mixes were higher. So there was some really strong positive trends are coming through, but we need to explore that data a bit more. But basically the mixes were providing some sort of positive benefit across all those sites. So some of the things that we've learnt to date, and these are probably nothing ground shocking, but they're probably just things that we've picked up along the way that we'll be trying to tease out later in further material. So consider the time of the feed gap that you want to fill. So you need to know what you're trying to grow the mixer for. So there's no point growing it if it's not going to help you with that feed gap. or you don't have the animals at that time of year to actually utilise it. Choose species that are suited to your climate and soil type and capacity for utilisation. So once again, know what you want to grow it for, how you're going to use it, and then get some best local advice on what species and suit your soil type and environment. Know that some species or some species groups are going to provide feed at different times in that growing season. So the brassica typically will provide a good early feed, good high quality feed in that early period, whereas a late maturing clover, particularly something like arrowleaf, might provide you higher feed in that higher quality feed in the spring period. So know where you want to have that distribution of feed and quality. And seasonal conditions will have an impact on what species perform best in the mix in any given year. So once again, it gets back to that crystal ball. If we knew exactly what sort of season we were going to have, we could go a certain way, but by having a diverse range of species in there, you kind of buffer against any seasonal conditions. Sow early in your window or sowing window if you're able to, because that means that you're going to have higher quality feed on offer quicker. And having said that, this is a case of do what I say, not do what I do, because I have never sowed at the right time in our sowing window across the whole experiment, because we've either been too wet or too dry. But if you can get in and get it sown early, then you potentially have feed on offer earlier. Sowing seed of different sizes can be a compromise if you don't have specialised equipment on your sowing machinery. But usually we have found that if you come up with a compromised sowing depth to meet the challenges of a large and a small seed, you will still get good establishment. So it's just a matter of trying a little bit sometimes to get that seed sowing depth right. In general, we found that we got more biomass from a mixture in all experiments and in most of the validations, so I should put a qualifier there. And in general, we got higher average daily gain from the mixes across all those sites as well. So what's down the track? So essentially the field work for this project is now finished, and we're in the stage of trying to analyse all the data, make sure we've got all the samples analysed that we need to and pulling it all together. And we're working on some case studies particularly from the on-farm validation sites, which will include reasonably detailed economics of cost of production. And then we're also developing a management guide, which should be released sometime next year, early next year, in the first half of next year. That'll take you through the process of understanding why you might want to develop a mixed annual fodder crop, how you would go around establishing it, and what some of the key points are around management. And just a last thing, this is a huge project across the state. There's lots of moving parts. We've added things as we've gone along. So I just would like to acknowledge that the team of New South Wales DPI researchers, technical staff in particular that actually get all the work done, development officers that have worked on the project as well, but also to the advisors and producers who provided valuable insights through our producer reference groups, which we've had involved with the project, which have helped guide some of the treatments and where we go, and producers for hosting on-farm validations around the state that have been really beneficial, and they've freely given their time and expertise. Most of them have had some experience with sowing mixtures, so it's been good to get their insights into the project. Yep, so the question was about sowing rates for the various mixtures. I kind of left that detail out of the presentation on purpose and was hoping someone would ask the question, just because we could go into an hour just on that. But in general, so for the grazing experiment, I'll use that as an example. The oats only was 80 kilograms per hectare. The mix was, we dropped the oats back to 40, the ryegrass was 8, and the brassica was 4. And then the same with the clover one. The clover was around about 4, but the oats and the ryegrass are the same. But we have varied different sowing rates throughout the experiment. So particularly the agronomy treatments, we would have had different sowing rates. So it's just to try and optimise that balance and number of seeds per hectare that you think you're going to get. Yep. I wish I had some tips, but so the question was, what are the tricks, tips to maintaining the clover content in the mixtures? That is one thing we have really kind of struggled with. Suze has had much more success with her legumes down here on the northwest slopes in her agronomy treatments. We tended to only ever have clover presenting at that sort of no more than 5% of the composition throughout the growing period. And that often is because in those wet years, the oats and the ryegrass grew very quickly and sort of shaded out the clover. This year, where we've had more even sort of growth, and particularly in the grazing experiment where we've had sort of pretty even grazing, we have seen higher levels of clover come in. So it's that getting that balance and making sure the clover gets established and gets a little bit of early growth happening so it is able to compete a bit more. So arrowleaf is later maturing, so it tended to grow later in the season, whereas Suze had some success with some other legumes that were probably more mid-season maturity. Suze, is that about right? Or varied, yeah. But it's a challenging component of a mix. It's not as easy as an oats, ryegrass, brassica mix is much more easy to kind of manage than the clover one. Yep. Yep. Yep, okay, yeah, so the questions sort of were around the economics and making sure that we're thinking about what happened before the crop in terms of crop ground preparation, and then what happens after the crop in terms of going into a permanent pasture. Yeah, we're just kind of getting into the economics bit at this stage, and we're working with an economist here at the research station to kind of get that data together. And I think we are certainly taking into account the prior ground preparation, so the chemical and any cultivation or that sort of cost. I'm not sure we've really thought about the cost of putting the perennial pasture in, but that's something we probably should be looking at afterwards, yeah.